Good afternoon, Rob.
Hey, Michelle.
Okay, so here we have the multiples, least common multiple, and greatest common factor task cards. Can you tell us a little bit about it?
Yeah, absolutely. So this is a elementary work. So I would categorize this maybe 7 to 10, 7 to 11 years old, depending on what level and how abstract you want to get with this work. For me, it reminds me of another one of those works that is, again, fairly complex as a concept, and yet it's one that the child has had indirect preparation for since the time they were 3. So we see, multiples, least common multiple, and greatest common factor. Well, multiples, if you asked a 3 or 4-year-old, have they done the long chain and the short chain? Have they done the squaring chain and the cubing chain there? Certainly. And those arrows that they were laying out when they were doing 3, 6, 9, 12. Well, what they were doing was they were laying out multiples, even if that was not language we would use with a 4-year-old. Any lower elementary child that says, hey, I'm going to take out the long chain, the cubing chain of 8, and I'm going to skip count by 8. 8, 16, 24, 32, well, what are they doing? They're actually calling multiples. So at some point in those elementary years, reporting out to the child that there's a nomenclature for this. We call those multiples, and the multiples of 2, the word multiple helps us with the language there. We're multiplying by. So what these cards do is puts it all together so that children see, like, okay, this kind of work is all connected to each other. Once I know what my multiples are, then the least common multiple is going to be easier for me to figure out because I already understand what multiple is. And okay, so multiples are made up of factors, so now I'm going to be able to find them. So one thing leads to the other in this really, really nice whole. The first section here, and as any task card is going to be, can the child do it independently? Yes. Do they need the teacher to get the answers? No, the answers are on the back. Is there language that's going to help them see the word multiple? It's going to help them see those words. Yes, there's nice language and vocabulary that's in here. And can they do it independently? This is great shelf work that is following the presentation that the actual child has done. So for instance, the first section deals with the decanomial box, and so the decanomial layout, which is another Montessori layout that we do with this big beautiful box that has chains from 1 all the way to 10. There's 55 in each. They do this layout, and now we're just looking at it as multiples. So what are the multiples of 7? What are the multiples of 8? And the child has the material to go with it. We're also looking at multiples, here, and so it says, using the table of multiples. What are the common multiples of 2 and 3? So we go through and we circle, okay, now that we've done this work, we know the multiples of 2, 4, 6, 8, 10, 12. What are the multiples of 3? 3, 6, 9, 12. All right, what do they have in common? Which ones did we do the same? Okay, we're going to circle those, we're going to circle those. So a new material, same continuation of the process, and certainly as a teacher, you've shown the decanomial, this can be a follow-up. There's lots of follow-ups to the decanomial, this can be one of them. You've shown the table of multiples, this can be one of them as well. So these next two deal with almost another material. It's a very interesting material in elementary years. Generally, usually, I would say more of the 8, 9, 10. I see this more often in upper elementary than in lower elementary. And there are these tables. There's table A, table B, and table C. I'm going to say it's a fairly unique Montessori material in that the material is the paper itself. And so Dot Game comes to mind as another one that's primarily, it's a written work. But what we have here and how we use it is, here we have a control chart, and it's commonly called Table A. And Table A takes all of my multiples from 2 all the way up until like 50 or below. And so 2 is able to go all the way to 50. The multiples of 3 goes all the way to 3 times 16, which is 48, so it doesn't go past them. And so we see the number that we're investigating here is here, and then in this column, the equals, those are all the multiples. So here are my multiples of 2, of 3, of 4, all the way up through 10. So that's Table A. Table B takes it just further. In fact, you could just, if you included one on top of the other, this just takes it all the way down to 100. This takes it all the way down. And we also notice because as the number gets larger, it has fewer multiples. So you've got this little pattern that's happening. So Table A and Table B are just that. So this is the control one. It has the answers. And then you would also have a table A and a table B available as a consumable, and they don't have the answers. And so for there, the child is filling in this part, and then they can use this to check their answers. So here, this material, these task cards follow up on that. List the factors of 4. List the factors of 24. List the factors of 50. Interestingly, it also says don't include 1 or 4. They're not really factors of each other, because the 1 is, every number has a factor of 1 and itself. Then this also, identify whether 2 is a prime number or a composite number. Okay, so how does the child do that? Well, once I've done table A and table B, and I've checked it with this, now I have table C. So I like it. It's nice and big. It's impressionistic. It's a larger piece of paper here. And here, instead of figuring out the multiples, this is almost the opposite. These are all the multiples here. And now what we're doing is we're figuring out the factors. Well, here we had factors determine multiples. Here are multiples. Now I almost have to just work backwards. And the child is using table A and B as almost like a source material to figure out the answer. And so they go through and say, well, what are the factors of 1? 1. What are the factors of 2, not including 1 in itself? 2. And the factors of 3. But then they get to what are the factors of 4? Oh, I can get 2 times 2 out of that. 6, 2 times 3. We start getting to larger, and 12, I can get 2 times 6, 3 times 4. So again, this is a consumable, so they're writing their name on it, and this is theirs, and they're doing it. But as a result, I'm going to have, some of these numbers are only going to have itself, and the part of the presentation that we give to the child is, because that's special, write that in red. And so 1 gets written in red, 2 gets written in red, so does 3, so does 5, 7, 11, 13, 17. And so then we say, okay, we call those prime numbers. All the other numbers are called composite numbers. So now you have a set of task cards that just is around that concept. So, don't include 1 or 4, list the factors of 49. In here, identify, is 2 a prime number or not? Well, we can tell because we can look on that. If it's written in red, we know it's prime. And so to identify whether 8 is a prime number or composite, well, we look down at our table that we created, the child created themselves, and we say, oh no, 8 has factors, so therefore it's not prime, it's a composite number. And then finally, using a material that we normally use for things like squaring and square rooting, which is the pegboard, we can also use that to determine whether we have common multiples. And so just like we said that we're going to find the common multiples of 2 and 3 on our table, we can also lay out 2 and lay out another 2 and lay out another 2 and lay out 2. Meanwhile, we can be laying out the 3 and 3 and 3, and anytime they match up, we know that we've got a common multiple, and there it shows the child. So again, it's nice that it's illustrated because it shows the child what their board is going to look like when they start, and what it's going to be when they find that lowest common multiple. And then finally, the last one also shows us, this would be the step right before abstraction. It shows us how do we find the common multiple of 2-digit numbers working on this. So now we're going to have to do exchanges as we go along, but the same thing, we're going to have our final answer at the end, and a nice illustration there so I can do it independently. So a lot of work, a lot of different materials, and a lot of moving towards abstraction at this point.
Thank you so much.